Let's see if we got this going. Check it. Looks pretty good. Looks pretty good, everybody, as we're coming in. I know it's a little early for the US crowd, but hopefully we'll get some people in here. Get this started. Hopefully, I'm still trying to work on my levels on the audio. Never know what is good on the audio, but it is good to see everyone here as we get going on this Friday morning. And it actually is Friday morning this time. It's been a while since I think I've streamed on Friday, and I know it's especially been a while since I've streamed twice in 1 week, but I think this is a good reason to stream, a good reason to talk about today. And if you kind of have like the thumbnail pulled up or whatever on in chat or whatever, that is kind of my thing. I never thought, you might have never thought that this would be the day would come where I would be talking about working nicely with Allen Bradley. But we are talking about today playing well with Allen Bradley. And I'm trying to get my chat pulled up here on my phone so that I can actually see you guys. There we go. That's much better. Hopefully I'm muted, and we're gonna go from there. But yeah, so as y'all are coming in, welcome to the stream. My name is Jason Watts, and if this is the first time to your stream, my name is Jason Watts. Been doing automation for about 20 or so years, or 20 years, about 24 years or so, and own a little automation company called Alpha Industrial Technologies out of the southern United States, out of the good old Alabama. I live in Atlanta, but this stream is honestly have a lot of people from all over the place. So as you come into chat, drop a hey and tell where you're from. We've got someone from Algeria in here right now. And it's one of the things about Siemens is it definitely is an international community. We do have a lot of people in these streams and in these chats and kind of watching these videos that are using this stuff abroad. Because if you're in the US, you might be, oh, well, Siemens is one of many of the kind of competitors to Allen Bradley, because Allen Bradley is the #1 automation distributor or automation company in the US. Well, everywhere else on the planet, no one knows about Allen Bradley. Not really, but Allen Bradley isn't very used very much anywhere other than in the US. Everywhere else is pretty much Siemens. And so, yeah, we kind of go through that, and yeah, we've kind of tried to bring this technology into the US, and it's some really good stuff, and not really talking anything about Allen Bradley, but I personally think that Siemens is the better product, is the better portfolio, and it's a lot more flexible, and sometimes that's not necessarily a good thing, and we'll kind of talk about a little bit of that in the stream today. But I'm gonna have to get this turned down in my ears. It's a little loud. It doesn't look like it's too loud for you guys, but yeah. But yeah, we're going to be talking about how to communicate between Allen Bradley PLCs and Siemens PLCs. So this is going to be from the Siemens perspective today, because we are Siemens oriented, as I've been saying on this channel. We're going to be using a little block called the LCCF it's out of the LCCF library, which is available on Siemens, and we'll talk about that. I'll show you the link. The link's in the description below to the Siemens support website, where all of the documentation for this library and the library itself is available. So that link's already there. So if you're coming on and you're on a PC, go ahead and pull that up, and you can kind of follow along with the documents and everything that we're going through. Because one of the things that I've come across, so Alpha, my company, we do a lot of we do a lot of technology and a lot of stuff in the agriculture industry, and a lot of our projects come through and they 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 have a like full greenfield plants, and we have a lot of pieces of equipment from a lot of different manufacturers. And while we are doing the main control to where we're controlling most of the kind of conveyors and coolers and pellet mills, and there are controls, we'll have some systems that kind of come as a package. And we're going to be talking about one of those systems today. It's actually a drying system from a company called Scott. And so far, this company has been really great to work with, and their equipment looks really top notch. And we're using one of their dryers in a very large facility in the Midwest. And you'll see kind of like in the software that we pull up today it's kind of its own kind of turnkey system. And it does its thing and has a lot of controls, and it even has integration into burner control systems that honestly, from just a general perspective, we want to make sure that whoever's doing those controls have their controls top notch, because if that dryer system doesn't work, we don't do anything in the plant. Like, we have to be able to dry things to be able to do what we're doing. So we want to make sure that works really well. So Lucid in chat is talking about how Allen Bradley users' kind of biggest complaint is about how Siemens technology is so complicated. And there's a little history behind that. And I kind of go into it just a little bit, kind of talking about this. And if you're coming in on demand, and you could kind of skip ahead to the technical portion, or skip ahead to whatever part that you're wanting to look to. We're going to go through the documentation on this CIP block a little bit, and then we're going to go into the technical implementation. And if you're watching it live, you don't have chapters, but if you're watching it on demand, definitely you could skip ahead. But we're kind of talking about the history between Allen Bradley and Siemens. Allen Bradley comes behind, and out, I guess it was in the 80s, you really started having these controllers and things that were coming in to the market in order to automate systems in industry. And Allen Bradley came out with the PLC. They came out with a thing that y'all may know called ladder logic. And for 90% of what was out there, it was replacing relay logic. Clyde, what's up? We got members in the chat. It's great to see everybody that coming in. We're just giving a little history right now on Allen Bradley and Siemens, because Allen Bradley came out with ladder logic back in the 80s, and it kind of revolutionized the way that automation was written. Before then, you had kind of these VME bus type systems that were almost embedded system platforms. In order to do any sort of automation, you really had to be an embedded systems programmer. And so working with assembly language and microcontrollers and things like that, developing your own hardware, it was a very technical world. Well, Allen Bradley, when they came out with ladder logic, it combined this kind of relay logic that you saw out in a lot of industrial facilities and industrial places. And you will see that type of logic to where it's literally just relays, coils, contacts on relays doing logic, hardware timers, things like that. And it did really well when you're going from the Model T assembly line to so what time is it here? It is 10 o'clock in the morning here. So yeah, if you're coming in, and tell me what kind of what time zone y'all are in, because I noticed that if I can get Central European time zones in, and kind of maybe Eastern European, that those are the better streams to talk about. And so 10 o'clock seems to be able to get some of you guys on here. So it's 8 o'clock, almost 8 o'clock there. So you're half hour off from where we are. So, but yeah, so kind of going back to this Allen Bradley bringing in ladder logic and kind of making it more accessible to most of what the control was out there. Because if you want to turn on a motor, you turn on a contactor, you turn on a starter, it comes on and runs. And that's the bulk of control, especially back in the 80s. There wasn't a lot of processing that was being done on these machines. It was really just trying to turn on and off relays. So ladder logic does that really, really well. And Allen Bradley got a name for being accessible and easy to access. Well, Siemens was still making these PLCs, but they were using what was called statement list, so STL. And statement list is, no ifs, ands, buts about it. It is assembly language. And what happened was when Siemens started sending equipment, or I guess European companies started sending equipment over into the US, and it was all written in statement lists, all written in assembly language, and not in this ladder logic. And you have Allen Bradley users that are sitting here used to this very easy to understand ladder logic for their process, and then in order to do the same thing on a Siemens PLC, because it was written in STL, they're having to basically learn assembly language. And so it very much was complicated back in the early days. And so you get this kind of divide back in the 80s and early 90s of even in the early 90s, Siemens with their S7 processors and S5 processors even had ladder logic, but most of their logic, most of the machines when they came over into the US were written in statement lists. And so Allen Bradley users got this idea that, Siemens, you have to use assembly language. And even though all the early 90s there were ladder logic programmers in Siemens processors, it just wasn't used. So we see where that has very much changed. And part of it comes from I personally, looking at the different software packages, and I'll admit I don't use Allen Bradley that much, and so, but what I've seen in RS Logix and Studio and all of their software packages is it kind of looks and feels like it has for quite some time, and there hasn't really been much of an advancement in kind of the environment, the IDE of Designer, Studio, all of those packages that for Rockwell PLCs. Whereas when Siemens came out with TIA Portal back, honestly, way too early, they were trying to make it use modern tools in order to make it much more seamless to program. And now that we've kind of gotten higher up into the versions of TIA Portal, I personally think that TIA Portal is much easier to use, especially from the limited that I've seen, being able to drag and drop between your HMIs and your blocks, just being able to bring in variables so much easier, create variables, create memory areas, doing some of the function blocks. And yes, Allen Bradley has add-on instructions and subroutines, but because of the nature of kind of generally Allen Bradley programmers, you get this kind of, I don't know, not necessarily aversion, but people don't quite use add-on instructions maybe as much as they could, whereas Siemens programmers kind of intuitively, as they learn Siemens, they learn the power of function blocks. And that's one of the things that we talk about a lot on here, and I'll show you in this stream, is the power of function calls, which in Allen Bradley world, it would be like a subroutine, and then a function block, which is similar to an add-on instruction. It creates this portable code that you can kind of just bring in anytime you need it, and then you can use it. And I'm going to show you how I did a stream that talked about this SIP block about a year ago, and I have an edited video talking about it as well. But I wanted to go really in depth about some new blocks that I made, and actually just this week, and kind of wrapping up some of the things that were a little difficult with this block previously. And I've made some blocks that kind of take away some of that pain. And if you didn't know this, if you're new to the channel, we do have memberships, and part of the memberships for this channel is accessing these blocks that I'm creating and making. For this particular program, y'all aren't going to get the program that I'm using today, because this program that I'm using is the actual program that I'm using at one of these facilities in Indiana. So with that said, you can't get that program, but I am going to make available to the members of the programmer level of the channel the blocks. So we're going to have a SIP wrapper block, which is me taking this block available from Siemens, modifying it in a couple of, not modifying the block itself, but adding on to it a little bit of features that I think are necessary for full integration into a control system the way that I use it. And then another block that parses these tags in a way that makes it a little easier. And so members at the programmer level will get these blocks. And so even if it's just for a month, like, you might consider doing that membership. And I definitely wanted to thank all the members that are out there. And if you see someone with a star in chat, thank them for their membership and their monetary support of this channel. I appreciate it. You don't have to be a member to support the channel, though. I'm sure anyone that's been on YouTube knows that the algorithm loves liking and subscribing. If you're coming in on demand, there's a ton of Siemens content on this. And yeah, if you were trying to learn about Siemens, we do a lot of stuff here. So definitely subscribe. And if you're here in chat live, be sure to like it to get the stream out. Yeah, so Claude, absolutely, especially towards kind of like the end, I'll definitely be opening up. I'm going to try and be thorough but fairly quick about these blocks, but we'll definitely have some time to talk about questions and things like that. We can get add on to the end, but I really want to dig into this SIP block today because I think we've got a lot going. So what I want to do now is I actually want to bring up, let's see what we have here. Which one do I have pulled up? Yeah, Firefox. So we're gonna bring up this window here. So if you're not familiar with the Siemens support website, there are a couple of things that I want to point out. So the entry ID here, support.industry.siemens.com, you can do a free registration for that website, and that is going to be your hub for all things Siemens. And I guess I say that, like, I guess it's all integrated into the C portal thing now, but the entry ID that I have highlighted here, if you take that entry ID and put it into the search bar, it will directly bring up this page. So that entry ID, and I'm going to take and put it into chat for anybody that's on live. They can do and search the entry ID and bring up this client block. So this SIP client block, as it shows, enables you to essentially act like an HMI in terms of the way that the Rockwell controller handles your data, which is kind of interesting to think about because if you weren't aware, Siemens Comfort panels and Unified panels, they have a SIP driver, and so you can use this SIP, Common Industrial Protocol. You can use that driver to be able to pull tags, modify tags, all in and all you have to know is the exact tag name. And there's even some tools like a tag discovery tool for Allen Bradley, to where you technically don't even have to get given these tags if your OEM doesn't have things set up in kind of a lockdown, secured fashion. Then you'll be able to pull these tags. So we kind of talking about before. Sorry, my nose is itching a little bit, but we were kind of talking about before that we are using a dryer system that has a couple of different Rockwell PLCs on it. Well, we have an overarching SCADA system that controls the entire plant from control room. And in order to be able to do that, we could either tie those tags directly into the we could tie them directly into the SCADA system, in which that might be something that we might do, or we could use this SIP block to be able to pull back and forth data. Well, the reason we have to use the SIP block, because the PLC is controlling all of the conveyors that are feeding in and out this system. And honestly, there's some of the big motors that are on, and big drives that are on this system, that the Allen Bradley PLC is just sending set points over to our central PLC in order to control. And so that's how we're going to be using this block. And there's no configuration other than setting the IP address and potentially setting the gateway on the Rockwell controller. There's nothing else. As if you can use an HMI, on your Rockwell controller, then you can use this SIP function as well, which is kind of cool and a little bit scary. And we'll talk about some of the implications of that later. But the documentation we're going to go through here in a second, just talking about SIP, talking about this block a little bit, and so here's this Siemens support page is where you are going to have all of this available to you. There's a link. I'm also in the member archives. If you're coming in on demand and you are a member, this stuff is in the documentation folder that you're aware of. We talked about the members. I'm going to update the link. So if you're using an old link, I'm going to update that link for newer members, because we've had some members that have come and gone. So each month we're going to be updating that link. So go back in, make sure that the Google Drive link that you are using is up to date, so that you have access to that folder. So let's flip over now and show the, I want PDF reader, because I want to bring up the documentation. So make sure I'm still, okay. So first thing I want to talk about is the Common Industrial Protocol. So the Common Industrial Protocol is a device net, I believe, defined protocol in order to communicate to, I don't know if it's just Rockwell, but if you meet this spec, you kind of define this. And one of the things that I wanted to talk about was we're using a specific kind of set of options for communicating to a Rockwell controller, because there's this device, or this Common Industrial Protocol SIP path, and we're going to talk about it down here. So this SIP communication path setting, and which comes into play if you were trying to set not a control objects, a Siemens panel. So a Siemens HMI, if you're trying to set it up in order to pull data from a Rockwell PLC, this communication path is an option that you have to set up in your comfort panel or your unified panel. And that is because this is the SIP communication path. Normally what you will have is you'll have your rack, and you'll have one of two options for your Ethernet port. So your Ethernet port will either be built into your processor, which I can't remember which version, L32 or 36 or whatever processor that has the built-in Ethernet port. If it has an Ethernet port built in, or it has an Ethernet IP communication card in it, and that's how it's communicating Ethernet IP. So either one of those types of paths are supported with this SIP block. There is another way that there could be that you could use an HMI in order to get to that data, and that is this kind of case 3, which is through a secondary gateway. And if you notice the different communication paths, let me get this a little bit bigger. Page width. So if you notice, the communication path here is fairly simple. It's 1-1. It's because we are taking our the first hop. It goes from left to right. The first jump is kind of the where does as my device or as my data comes in, where does it go? And 1 brings that data into the back plane, and then the next number here is what slot on that back plane does it go to. And in this case, you have X1, and so it's going, the data's coming in, and then it's going to slot 1. So that's where slot 1, it's coming in and it's going into this back plane. So that's kind of how you can look here. Now, there are other things, like if you were to come in and then you're going to this Ethernet switch here, you might goes to the back plane and then to slot 0. So that's what this 0 is here. And that's going to be important when we set up our block, and you'll see why. Now, there is a kind of this third case, which you come into your data, or you come into a remote rack, go through the back plane of the remote rack, go out to across some control net into the back plane and into your PLC. Now, this is weird here because they have 2 different IP addresses like the Ethernet. Why would you just not go in here and go through the back plane? Whatever. This probably isn't here in this scenario, and that's why. But that communication path, you can see it comes in, goes to the back plane, goes to slot 6, goes out slot 6, goes in slot 2, and then at address 22. And so that's where we're going out and in, and then at address 22, it goes into the back plane, and then we have, I guess, slot 1 in this case. And so that's where this communication path, that's how that works. This sort of kind of like interconnected device gateway sort of thing is right. So that sort of like that connection is not possible, and it shows it here that this scenario is not possible because it only has that one jump. It needs to go to the back plane first, and then it can only have one jump, and that's just a limitation of this block. Now, you could absolutely go through and either modify the block or modify, kind of take and do the same setup and use this SIP functionality to go in another way. But honestly, at that point, you're probably going to want to look at another option, a hardware option that we're going to be talking about later. And so we'll definitely go through and go through some questions later on in the thing. So yeah, so that's one thing that we need to know about, is this kind of the fact that this pathing is built into the SIP protocol. So let's go through and talk about a little bit about, I guess let's go into TIA Portal, because I want to I want to talk about this because what we have here is the wrapper block for mine. So this is the program that I have, and again, the members won't be getting this full program like they would normally if we make a program on screen, but you will be getting these two blocks here. I have this Alpha Industrial Technologies Allen Bradley interface block, and I'll show you it's a wrapper for the LCCF CIP client block. And then I have this CIP tag parser block, which if you notice, this is a function call and this other is a function block. We're going to go through and kind of talk about why these are necessary. So if we were to go into my little Allen Bradley interface here, I'll show you, you have this LCCF CIP client block, and this is the actual block that is in the library, and it contains everything kind of built into the block to be able to communicate with your Allen Bradley processor. So let's talk about the inputs and outputs on this. The inputs are you have an enable and you have an enable bit, and one thing, the reason why you'll see some stuff down here, if you were to just remove the enable, I found that there were some COM errors that would break the internal TCON blocks and kind of mess them up to where they weren't getting reset properly. And so what I did is I came up with a scheme to where this block, I could actually reset individually inside those blocks the TCON values inside the blocks and get it to fully reset. And so that's what the auto reconnect, auto reset functions that are down in my block, that's what they're doing. And so the interface that is here on this CIP client is the Profinet interface, and I'll show you out in mine because I'm just passing that through. This is the actual port that your PLC is communicating to. Now on my processor, this 1515TF, it has two interfaces. It has two network cards. It has Profi interface 1 and 2. If the easiest way to get this hardware ID, we talk about hardware IDs a lot in the drives portion of our stuff, but we want the hardware ID of the Profinet interface. Just start typing Profinet and it will pop up the two interfaces that are available for this processor. If you're using like a S7-1200, yes, this block will still work, but it will only have one interface. As a note, if you don't know which interface you're using, you can always bring up device and networks and go to this view and hover over your PLC, and it should say that this is either Profi Ethernet 1 or address 1 or address 2. Maybe it's here. So I'm clicking on this show IP addresses block, and it will show you which address or which port you're connected to. So, by the way, this is a big project. I have almost an entire subnet worth of IP addresses on this project. It's quite big, so it takes a little while for those to come up. But see, you can see this is on PNIE_1, and that is actual. It's under actual the number 1 interface, so Profinet interface 1, and then here is Profinet interface 2. I want to say that there is a, yeah, right there. So X2 and then X1, and I think, yeah, there you go. So, right. So anyway, so that we're on X1. That's normally the one that you would connect up to. It is the one with the 2 dual ports, is Profinet interface 1, and on a there's a separate port that is for kind of whatever communication, but it is at port X2. So that is what that is. So we started typing in Profinet. We select port 1 on Profinet interface 1, and that's what that is. Going back into this block, we have our server IP, and I'll show you that this is up in this input block that I have set up, and it is of a type IPv4. And now that is a built-in type, but unless you have used it before in your project, it will not auto-populate. So what you have to do is just type in IP_v4 and then hit enter, and TIA Portal will recognize it. It just won't auto-populate if you haven't used that type before. And then we have our AB SIP slot number, which we kind of talked about before, which is this slot. So if you're using the internal port on your Allen Bradley processor, then it is going to be slot 0. And then otherwise, it's going to be on the slot of your Ethernet port or your Ethernet card in your rack. I say yours, like it's probably not yours unless you're teaching this or showing this to somebody else and kind of learning about this. It's probably your vendor, like ours. Our vendor has used this Allen Bradley slot or Allen Bradley processor. And so I would go out there and be like, okay, they're plugged it directly into the processor, so I'm going to use slot 0 in this. Fairly simple. The update rate is fairly. Yeah, so the update rate, by default on the LCCF client block, it is 10 milliseconds. So this, you can update this, kind of try to update it as fast as possible. You might get some errors, but the internal TCON blocks can run just like a normal Ethernet kind of communication back and forth. So you can expect to be able to do down in the order of like of 20 to 30 milliseconds on these updates. Now that may not be enough for some processes, but most things, even if you're doing like starting and stopping and getting updated values, if you're inside of really 150, 200 milliseconds, like that's pretty good. Like, so I set this default on mine as 100 milliseconds, and that is being passed through. And so you can modify that. And so the next thing that we have here is this SIP tag. And this is one of the things that is a little bit of a big difference between Allen Bradley and Siemens, is the way that we handle tags. And yes, a tag is essentially a name for a memory area, but the way Allen Bradley does it is they do like true tags. They are creating the tag. They create a tag that takes up a memory space, and then they might alias that to some sort of input output. Well, in Siemens, it's almost it's really kind of a pseudo tag, because the tag is more directly aliasing the memory that you are working with. And that doesn't sound like much of a difference, but in Allen Bradley, everything is 32 bits. Everything is a double word in Siemens realm, even Booleans. So a Boolean value in Siemens is a bit. So it takes up 1 bit, and you can see this because you can pull out .1, .2, .3, whatever of a bit. A Boolean value in Siemens takes up 1 bit. In Rockwell, a Boolean value takes up 32 bits because it occupies the tag area. Well, in our case, that's a problem because if we have a Boolean value, and then how are we converting a Boolean into 32 bits? And so this tag type and this tag, like the SIP tag, that brings up a little bit of an issue. And that's some of the thing that we do in our tag parser block that I'm going to show you in a second. That's why it's there. Let's look at the definition of this SIP tag. So, by the way, if you're not aware of how to download and install the library where this LCCF library or SIP library, what you would do is you would download the files from the support website. Then you would go to libraries in your version of TIA Portal, go to global libraries, and in this case, pull it up. You would click open a global library. You would find that global library, and in this case, LCCF SIP client. You would extract it. And here's one thing that I noticed: this LCCF SIP client block came in as a compressed archive. So it was originally compressed, and so nothing was showing up. And I'm like, I know that this is extracted to this folder. Well, flip over to compressed archives, and you can see, okay, my compressed archive is in that folder now. And then it will unzip, and you will get this LCCF SIP client. I already have it open in mine, and what you could do is, if you are using a project library, and for me, I most definitely am using a project library, you can just take these types, and you can see there's types for 1500S, which is like the SPs, like the integrated controllers, and then you have 1200s and 1500s. I just took these types and just took this and just drug it up into my types up here, and then that way my project library has that link. But you're going to need to drag those things over into your project. Now your data types will need to be drug into your PLC data types folder. So I have my SIP 1500 data types. I just drug that whole folder over into it. And then you will need this block LCCF SIP client. You will need to drag it into your actual program blocks. And I think I put that, SIP 1500. There you go. And so I brought that in, and that makes that code available for you to use in your blocks, in your functions, in your project. So, and then it's just a matter of dragging this block into, for instance, this function block that I'm making, or I made, called my AIT Allen Bradley interface. And I just drag that block into here and start populating it. Now, again, you're going to have an instance. And for me, I made an instance, an LCCF SIP client instance, in my static memory of this function block. And if you're not familiar with what that is, you probably want to check out, I've got some edited videos about what's the difference between OBs, FBs, and FCs. You probably want to check that out, because this static area of memory is really critical in understanding how to make portable code to where you can just drag and drop this block and use it over and over again. So we've got that here, and it's linked, and just like any good function block, everything has your hashtags on it. That means everything is in local memory. It has memory local to it. This block will be able to be used on anyone else's 1500 processor. And so all of this stuff goes through. So we've kind of talked about this. We're going to go through the SIP tags here in a second. The last things that I put into my block was a watchdog, because the SIP block itself has an error. So it has valid and an error. So if your data is valid, that's going to be true. If you have some sort of communication error, some sort of problem, the error signal is going to be true. And then it has status and diagnostics that you can also do. Well, the issue is the Siemens PLC can see that the communication has dropped. Well, remember, we're not changing any hardware configuration on the Allen Bradley processor. Frankly, we don't even have to change the code on the Allen Bradley processor as long as we are on the same subnet. So if that Allen Bradley processor is relying on the communication, so the dryer, for example, is going to have a run command that's coming from the PLC. It's also going to have a, hey, the exit conveyor is running. Hey, these drives are running. So that Allen Bradley PLC needs to make sure that it knows whether or not there's a communication error or not. So there needs to be a watchdog, which, if you're not familiar with what a watchdog is just a pulse that is supposed to be on or off for a given amount of time. And if either the watchdog is on for too long or off for too long, you know that your communication is not toggling back and forth correctly. So in this watchdog, I have it, and you notice it's a Boolean value. It's a single bit that I'm just toggling on and off, but I'm having to use the move instruction because I'm having to move a double integer into this value of this AB tags 0. So I set it up to where my watchdog is always going to be the first tag in the tag or in my side of tag list, and I'll talk about it in a second, but that's what this watchdog is. So Siemens PLC, it knows whether or not it's communicating to the Rockwell, so it doesn't need a return watchdog pulse, but it is just going to sit here and toggle on and off this watchdog pulse. And depending on how long your delay time is here, so if I'm only updating this every 100 milliseconds, this delay time has to be more than 100 milliseconds because otherwise it can skip and what gets sent across doesn't actually toggle. So this will probably be a 1 second on and off. And then a watchdog timeout on the Allen Bradley PLC will probably be on the order of about 5 seconds. So the last thing that I kind of talked about is these auto resets. I found that if there was a reset from or a network communication problem, something to do with either a network cable or the gateway being changed or some sort of IP address. Sometimes if inside the panel a network device got shut off that prevented network communication to this, that I don't know what it was, but there was sometimes the internal SIP communication block wouldn't reset itself. And so there is quite a bit of logic here just to be able to reset this block. Now, so we're going to go through, and now I want to show you these tag definitions. And if you notice, that's kind of the block, pretty simple block there. So I'm going to close this out because that's my internal interface. Well, there's two things that you need to have. You need to have a list of these tags, and then so these SIP data tags, these LCCF SIP tag definitions. So you need to have an array of those, and then you will need to have your actual process tags that you are using, because Siemens, again, a bit or a Boolean is a bit, an integer is a word, a real is a double word. So you have multiple sizes, and then you have to shove them into this data type. So I'm going to bring up what I'll show you. So this is kind of my bare minimum kind of example database. So you have an data block, I should say, not database. You have an IP address that you used in order. This is the IP address of the Allen Bradley processor, and it is of that IPv4, which this is that internal definition. And these are just 192.168.0.10, whatever. But here are these SIP tags, and if you notice, I just have an array. I have two tags here, array 0 through 1 of LCCF type tag definition, and that is one of the PLC tag or PLC types that is available in this library. So yeah, let's look at this. So tag 0 is our Boolean for our watchdog. Now, remember, we are looking at this tag from the perspective of the PLC, the Allen Bradley PLC. So what we would want to do is set the, so these are single quotes set inside this. I would set it as the start value, because that way you don't have to retain the value here. Set it as the start value to be C. Now, for this one, the Allen Bradley processor probably doesn't have this tag. So in this specific example, if you're wanting to use this watchdog, this first one is going to be toggled. They're going to have to create this tag, and then they're going to have to use that tag as a watchdog. That tag is going to be pulsing. If it stays on for too long or stays off for too long, they're going to have to throw a communication error. So that's on the Allen Bradley PLC side. Now, I might have a tag on the Allen Bradley side that they are already using, and they will not have to make any changes for this. Say I want a status of that the dryer is running, and they have a dryer underscore running tag, okay? And it is a Boolean value on their processor. Now, Boolean, again, Boolean on Allen Bradley is not the same as Boolean in Siemens. So we have this tag type, and if you notice, it's a word. And so we have to define what type of value this thing is, so we know how to interpret what is actually shows up on our end. And so let's go back into the documentation and look at this tag type definition. Oh, where is it? Operating appendix, CIP block, parameters. Maybe it's here. Oh, here it is. Yep. So under manual tag list creation, there is a tool-based tag list. I'm not going to go through that. I feel like it's fairly easy to set this data block up by yourself, and you're going to really want to understand how this data block changes as you are adding in tags and going from there. So our Boolean, a Boolean value, this type code in our tag needs to be 00C1. So 00C1. We can have 00C2, C3, C4, CA for a real, and a double word is going to be D3. So I'm going to show you how I handled this. Inside my block, I have what's called a CIP tag parser. I'm going to open up this function call, and in the actual constant area, I went through and defined these as words and as their default values being this Boolean, integer, double int, and real, so that when I go through and if I open this up and I want to see inside this block, I can see, oh, this is a Boolean if the tag quality, which the quality is whether or not it is good or bad. So this will be either a G or a B. And so we're going to check if we're not writing, it's only a read. If we're not writing and we know that the data is good and the thing is a Boolean, the tag value, we're trying to read in this tag value. Now, in the way that the Boolean works specifically is if it is 0, it's not 0. I mean, it is 0. So if it's 0, it's all zeros. If it is 1, it's all ones. So all 32 bits, or all 16 bits, the first 16 or the least significant 16 bits are 1. And so you see this kind of, it's a little bit of error checking right off the bat, because you'll have all zeros you can count as a 0. But then if the first bits come up, like the least significant bits come up as being 1, that's going to be a 1 value. And so this is what you could see here, fairly simple. And then the read Boolean is, I'll show you more about this block, but you have to do this kind of like, hey, if it's this type, then, and it's this word value, then read this. And so like that double word is the double word value that is in this tag. So let's go back to our tag list itself. So we have a dryer running. Our tag type is, again, I've got the wrong one up here. So we've got this back here. It's talking about this tag value here. Sorry I didn't have Portal up. Awesome, welcome in. We've got some people in chat coming in from Yemen. Welcome into the stream. If this is your first time on stream, welcome. And if you didn't know, we've got a lot of Siemens content on the channel. We are talking today about a CIP communication to Allen Bradley to Siemens processors. So I just spent a couple of seconds or a minute or so talking about something that I didn't have it up on screen, but here's what I was talking about. In the interface of my little function call that we're going to talk about later, I have these constants where I have programmed in the C1, C3, C4, CA that we were talking about before. And here's kind of how that works. So again, we'll talk about this more. If it's a type of Boolean, so a C1 tag type, we have a quality of good and a value of FF, which is all ones in the first or the least significant 2 bytes. We're gonna give an output of a Boolean read, or read Boolean. So anyway, let's go here talking to this. So this is going to be a 1600C1 because it is a Boolean, and this quality is going to be changing by the block. So one of the things that you may or may not know is that a function block can modify input values as long as it is registered as an input output. So an in out, the block, you can bring in the data, and it's really just a pointer at that point. It brings in the pointer, it changes stuff inside the function block, and then that gets changed and it kind of gets saved in the program. So the quality, you're only going to be reading, you're only going to be looking at it because the block is changing it from good or bad. This tag write we're going to talk about, if you write to the tag, then you can actually write values on an Allen Bradley processor without changing the code on the processor. The processor doesn't even have to be set up to make these changes. And so that might throw a little flag like, whoa, wait a second, you can modify values in someone else's code on someone else's PLC without changing any sort of configuration on that PLC. Yes, you can, doing this. It's very similar to the puts and gets functions that you get in Siemens PLCs. So like ignition platform, any SCADA platform, any HMI that is communicating into your processor has the ability to change values. So it's the same thing, and we're using that same kind of like entrance way to, we're acting like an HMI in order to make these changes. And finally, finally on this tag, we have the value. The value is always a double word. And in our parser function, it goes through and has a couple of conversions depending on when you bring in this value, depending on what you are using, what is the type, then it will output things for whatever you're needed. So let's go through, and this SIP tag, let's take a look at the parser block in full and how it is used. And again, this is my block, and to be honest, I haven't fully tested the write values, and I might need to tweak some ordering in that because I don't have an Allen Bradley PLC here to do that. But I'm in not even 2 weeks, I'll be working with this dryer company to do that. So if we're not able to write the real values, I know I'm able to write the Boolean values, no problem. If we're not able to write the real values, then I will let you know, and I will update that block, and I will push out an update to all the members that have that block. So this tag parser will bring in as an in and out, the tag that you are wanting to parse. And so we have this data block that has our SIP tags. And if I wanted to add a tag, I would just go through and say data block 2, and then hit enter, and then now I have an extra tag. And so all I'm doing is changing the total number of indexes on this, and I'm getting more and more tags, and I can go extreme with this, and I now have more tags. That's the beauty of these data types. So I'm gonna go back to just our 0 to 1. 0 to 1, because that's all I'm using right now. And later on, I will go through and just add. So the beauty of setting up this data block like this is all you have to do is set up your COM block. So this is the PLC that I'm communicating to, this Egan SIP comms. So, and I have an instance of my wrapped up LCCF SIP client block, and then tag parsers for all of the tags. And I'm running the tag parsers in front, so above the SIP wrapper, just because I want, remember, this block is modifying this block because this is an in-out. So you can see there that it is an in-out. It is modifying these tags in some way because we're wanting to write them. We're actually shoving stuff into that write value. So this SIP tag parser takes, if you are going to write, then you give it the value you are wanting to write to it. And inside this value, if you change the Boolean write value, either through for example, I could do this and call this Egan PLC data, SIP tags 1, tag write. I can call that directly. So if that tag write value is on in this tag that you pass, this block will take whatever input of the tag type that's already defined in here, and it will write this value here to that tag, and it will get sent over and updated in the Allen Bradley PLC on the next call of this block. So that's how this SIP tag parser works. So if you're going to write something, you have to have this populated. If you're going to read, which if you want this back into your system, then that's what you want. So you can see here, we're using this SIP tag 1, which we have defined over here as the Allen Bradley tag name, and this has to be case sensitive, exactly the same as the tag on the Allen Bradley PLC. So in index 1, we have set up this tag, and we have thrown that tag. And remember, if we want to get access to that, we can go to Egan PLC data, go to details view, SIP tags, and then we can just drag this over into here, and it will populate that tag into this here. And so it just drags it into it. Now, if we pick the wrong thing and try to drag it here, it'll give us an error, because this is defined as an LCCF type tag def. So it has to be that tag definition. So if you accidentally drag the wrong thing, it will complain and it won't let you do it. So it takes this tag and parses it. So it's a little complicated inside this block. And this is why before when I talked about this block before in live stream, I didn't really go too in depth in this, because I didn't have a really good way to present that to you to say, hey, here's a way that's real easy. Here's a block, here's a parser. Well, with this parser block that you get if you are at the programmer level of a member, it will actually parse out these SIP tags. The writes, kind of the same way. It's looking for if that tag write. So remember, that's tag in, that's that tag definition tag write. So you have to externally change that bit in that tag to write it. If you're always writing it, for example, like what we're about to do, I'll show you how to set that up. But in this case, the dryer running bit is always going to be a read. So that tag write is never going to be on. So it'll always be pulling this. It'll only update the data if the character is good. Now, I may go through, and this is one of the things that if there is a value that you would want to set the actual value to, you would want to have some sort of error to where you say, hey, if it is vital that if I lose communication, if my tag value or my quality value goes to B, it goes bad, you will have to go through and say, hey, make that decision on your own of what do you want to do? Do you want to keep the last value like this block will be doing? Or do you want to substitute like a 0 value or a 100 value, whatever it is? What do you want to do in the case of a bad value? And that's what it's going to be up to you on this. So just to kind of show you how to use this block, I'm going to make a second tag, which is this dryer. In order for it to start producing material, it needs to know that the conveyor that it is dumping onto, that is controlled by the alpha PLC, it needs to know that that value is on. Okay, that's fair. I'll show you how we can do that. First, we need to make that tag in the PLC. The Allen Bradley PLC needs to have that tag. And we'll work with our vendor to make a new tag. But on our side, we're going to add in another SIP tag, and it's going to be a default tag here. If you notice, if you set these start values here, nothing's changing here. Say that the vendor wanted to call this SCADA downstream running, okay? And they wanted that to be a Boolean. So we know that that is going to be a C1, because that's a Boolean. That is not going to be good, or that is going to be updated by the block. And we want it to always be being written to the PLC, because the PLC should never be changing this value, because it should be looking for this communication coming from our PLC. So we're just going to change this to default true. So now this tag 2, is set up to be connected to, on the Allen Bradley side, a tag named SCADA downstream running. Cool. Now in our control block, we're going to, you can do it one of two ways. You can either make a new network, so you can kind of split them up, or you can put them all in the same network. And you're going to take this SIP tag parser, you're going to drag it onto this block, and it comes up with all of these different things. Okay, so we know that we are going to be writing a Boolean, right? We know that we're going to be writing a Boolean. And in this case, that Boolean value is going to be found in one of these equipment IDBs here. And it's going to be, I want to say that it's this. Let me see. Let me find what it is. I want to say that it's that one. But the way that we have it set up is we have a sequence delay that when that piece of equipment, oops, not sequence delay. It should be sequence ready. Had the wrong thing. You notice, again, I set this sequence ready is a bit that comes out of the control block for that conveyor that says, hey, I'm ready to receive material. That means it's running, it's not faulted out, we've got all the motion sensors good, it's cleaned out, it's ready to go. That's what sequence ready means. And so we want to pass that value into the SCADA downstream ready bit. And so this isn't going to be a dent, and it's not going to be a real, so we just kind of zero those out. It's not going to be used because our tag definition is not going to use these two values. Now I can go back to my Egan PLC data, go SIP tags, and I know that it's this tag number 2, or index 2, which is actually the third, but it's the second real tag. So we go there, and that's cool. Now, what do we do with these outputs? And this is one thing that you should know, the difference between a function call and a function block. A function call, because it does not have an actual data block associated with it itself, it is just a group of code, like a subroutine. It does not actually have the ability to have default values. So if we go and look at the difference between our interface here, our default values for these things, we can't put default values in, okay? So our inputs and outputs can't have default values. Whereas if we go to this interface, you can see that I can just leave these blank because our inputs have default values available to us. Those are default values in here, by the way. They're just buried. So our inputs and outputs have default values. So all that means is there's nothing connected here down in this function block, and you don't see errors. But in a function call, you have to have something connected to every input and output of a function call because there's no default value. It doesn't know where to point. So in this case, you have to have in your interface for this function call that we're making this, you need to have some temporary, some just like placeholder values, like junk variables that it's just, you're giving it some memory area to work with temporarily. It's, if you're a programmer, it's memory on the stack, or I guess memory on the heap, in order to just kind of use and discard. So we are going through here, and we're just going to add in these temp values: temp bool, temp dent, temp real, and then that's it. So for this write value, So just out of curiosity, so if y'all are watching on stream, and you get an ad break, you should be able to still type in chat. Will you throw in if you're on an ad break so that I don't go through? Yeah, so it looks like people may have been coming back from an ad break. If you're go into an ad break, will you type in chat, hey, we're on an ad break, so that I don't go through anything important while y'all are gone and y'all miss anything? Because I don't control where those ad breaks actually come in, and it'd be nice for y'all all to like not miss this. But because I was just talking about these temporary values here on a function call, you have to have all of your values filled in, because there's no default values in that. So we've got these 10 values, and that's it. So now what we have, we need to make our value that, in our case, since we are actually passing that value directly for this sequence ready, we're just passing that value to the Allen Bradley. We don't have to add in an additional value here. Well, let's say that we want to add in the drive, or the device set point. Okay, so we want to be able to control the temperature set point for some reason by our or I guess the feeder speed set point for this process. We may want to create a tag called dryer skater dryer speed set point. Okay, and we want this to be a real value. Okay, and there's a couple of different ways that we can do this. We can have the OEM, if we're talking to them and they're working with us on everything, we can go through and say, hey, will you program it to where you have this tag that we are going to send to you, that you look at it and transfer that over into your value, and that's your speed set point. Will you do that? And if they're like, okay, yeah, we'll create you this tag. Well, sometimes they may not want to do this. Well, remember, we're acting like an HMI. Well, we can go through, and if they have a value that's on the HMI and we know what value that is, we can actually modify that value just the same as if we were modifying it on an HMI, right? So in this case, dry dryer speed set point. Say they have a tag, so I'm going to add in another tag. So I'm going to create another length, because they have a tag called HMI speed set point. Okay. And that's the exact tag. And it is a real value. So we go and we look up, and a real is a type 00 CA. And remember, CA, this is in your documentation. And we don't want to write to it all the time, because we still want to be able to write that value out at the HMI in the field. Because the way an HMI works is normally it will just display whatever that value is in that tag until you change it, and then when you hit enter, it actually goes through and changes it, right? So what we're also going to make is we want this dryer speed set point. It's a real value, but we also want to kind of be able to say, hey, update this from the HMI, update this from our PLC. And so or we'll call it write and it's going to be a Boolean. Okay. So we have this kind of set up here to where we're going to have a speed set point value, and then we're going to click write, and that will go through and actually update during that time. It will update as if we are in HMI, this HMI speed set point value. Okay, and this way, normally an HMI speed set point is going to act this way. And so if your vendor, maybe they can't update their PLC program in a timely fashion, but they're like, hey, yeah, just use this value and just update it on a one shot. You can do it this way. So let's go in and let's set up a tag like this. So we've got another one of these CIP tag parsers. I'm just going to drag this in, and now we need to fill all this out. So let's go through and let's click on this, and we know that this is our CIP tag number 3. It's not a Boolean. It's not an int, but it is a real. So let's go through, and we want to pass this value here. This is the value that we're going to be writing, right? So we've talked about this before, but it's also changing, right? So this is one thing that you may want to have a value like dryer speed set point SCADA, and then dryer speed set point actual, like what's actually running on the value, because you have these over here that you probably actually want to have this here as well, right? Well, how does that get updated? I mean, that can lead into a bit of an ambiguous situation. So let's go and say and let's just duplicate this. Like this. Let's use that value there, because yeah, it's an extra real, but it just makes sure that we don't have any ambiguous situations, like where we end up writing to something in the same cycle that we're trying to or we end up reading something in the same cycle that we're trying to write it. I don't think we're about to do something here that makes it to where I don't think that would happen, but safety first. And then again, we're just going to throw our temp values in here like we did before, because the same reasons. So the problem is we're not telling the CIP block that it needs to be written to. So, and the reason why I think that it would be okay to do it this way, just using this tag, is because I'm going to actually go through and add in a little bit of stuff here like this for this. So I want to take this right dryer speed set point, and I want to pass and actually modify inside here this tag right. Now, we talked about this before. Remember, this is this new index 3 tag. This is the same tag that we're doing here. And when we press this button, however we press this button through an HMI, SCADA platform, whatever, it is going to write this tag, or turn on the tag write function on this in this here. And that's why I think this CIP parser, if we do it this way, you turn it on, it's on in here, and this CIP tag parser looks at and it discards all of the read values, right? So if that's on, it doesn't execute this code, and it only executes this write. And in that, it is taking and moving the values into that value. So I'm pretty sure that it would be proper to be okay with this, because your values going out would just end up being whatever. But it might just be that you would want to use that same value, because Yeah, I don't think it would work now that I think about it, because while you are typing in the value, while you are modifying that value, when it updates, there might be a cycle of the PLC that it overwrites. So you would probably definitely want to do it this way. Now that I think about it, even with this. So, well, I'll be testing this in a couple weeks. So I'll, again, verify that this is the proper way to do it. But honestly, this is how all the three different scenarios. You have a read, a value that you're only ever reading, a value that you are only ever writing, and then a value that you need to update periodically. And so that's what we have here. And this block allows you all three methods of doing this. Now, if I was on doing an HMI, I maybe wouldn't even have to have, actually I know for a fact, I would not have to have this value in my data block. I could directly access this value. So I don't have to have an extra tag that I'm toggling. That would be if I wanted to like use an input or something to like, if I had like a push button or something that, all right, update this tag, something like that, I could do it this way. But from SCADA, HMI, something like that, you don't actually need this. So yeah, I'm pretty sure that is it about the about the functions in this. And so I'm going to go through, and if y'all are coming in, you have any questions about this, and we're going to talk a little bit about some questions that we've had in different things. I'm reading some questions that are coming in from some of the members. I try to answer questions. Again, if you're not aware, and this is your first time on the stream, welcome to the stream. But we do have a Discord that's in the link to the channel, or there's a link to the Discord in the channel and in the description of this video. You can join up for free and communicate back and forth. And we've got members, non-members, subscribers, non-subscribers that are in there kind of talking about all sorts of different applications. So this time I'm going to talk a little bit about some questions that we had from that. And one of the questions that kind of brought up about this SIP block in particular is good applications of this SIP block, and when you would not want to have, because there's multiple options of being able to communicate back and forth. There's this option, but then there's also a traditional hardware gateway where you have a Profinet to Ethernet IP gateway. And one of the advantages of using the SIP method is the Allen Bradley processor doesn't have to have any sort of update to its hardware. The only thing that you might have to do is, if you are not on the same subnet of Ethernet, then the Allen Bradley processor would have to have its default gateway set to a gateway that knows how to bridge the Siemens network and the Allen Bradley network. Because I mean, come on, let's be for real. All Siemens programmers are really already scared about having Allen Bradley on their network, right? And so I get it. Like it's scary, but all jokes aside, there are a lot of reasons why you might actually want to separate that out. You might have multiple areas that are controlled by multiple PLCs, and you want them on different subnets, all of that. And so you would have to have a gateway device that the Allen Bradley processor is pointing to. Even in this, it would have to know how to bridge the two Ethernet networks, because this is using just standard TCP communication. The alternative to this is putting in a piece of hardware that sits on the actual hardware configurations of both devices. So you have these AnyBus gateways to where you set them up as a device on the Ethernet IP side, and you set them up as a device on the Profinet side. One big advantage to this is the fact that you have a gateway and you are actually using Profinet. You have a Profinet device and you have an Ethernet IP device. So there is a little bit more security in the communication between the two. And second, from a Siemens PLC perspective, you're not having to use what's called a connection resource. And on lower end processors, those connection resources can get pretty limited. I think at the lowest end of the 1500, you may only have 4 or 6 connection resources. And so while yes, you would be able to communicate to a device, it might prevent you from adding an additional HMI onto your processor, onto your system. It might prevent you from adding a SCADA network node onto it. And so these kind of built-in TCON blocks use connection resources. If you are on the Profinet network, then you do not use these connection resources. And so you can use an S7-1200 and not use up those, and you can actually have a gateway that kind of offloads that communication processing. So those are two different things. And I tried to look up Anybus's documentation for their Ethernet IP to Profinet IRT gateway, and I couldn't see for sure, but there should be a way, because you're having to use that device anyway. There should be a way that you could set up the Ethernet IP side on one IP address. And so it could be on one subnet, and then you have your Profinet side on a different subnet. And so it itself acts as that network bridge. And so there are some pretty good cases for using something like an Anybus gateway. And so I guess that is probably the biggest thing. And I just looking at that IRT, if you're not familiar with IRT communication, Profibus IRT is isochronous real. Sorry, warehouse at the lab here in Atlanta. Not the only one in here, but one of the isochronous real time means that there is a synchronous controller on the bus, and that Profinet device, that Anybus IRT compatible gateway, means that it is okay with having that actual controller, and it participates properly with that communication. Because I will say that, now that I think about it, is a real good reason to keep your Allen Bradley controller off of your network, or off of an IRT network, because Ethernet IP does not have that same IRT controller. And so if you were sending this standard TCP data across using SIP, there is a significant risk of that data not being corrupted, but being put at a lower priority level due to the isochronous communication. And it could lead to some communication issues. So if you're using IRT, you definitely want to protect your IRT network, have IRT compatible switches, have IRT compatible gateways. And there are also things as well that's like Rockwell drives, Ethernet IP drives. You might not want them on your network as well. That is one thing that I don't have any Rockwell drives on the network at my plant. I would probably use a gateway because of the kind of the communication methods that they use. UDP, they do a lot of like broadcast messaging and things like that in order to keep communications. Sometimes it can cause issues. So those are two reasons why I would say that you might want to use a hardware implementation of this gateway instead of this SIP communication. But if you're just trying to pull some standard data, I think that this is a good. I think this is a really good block to use. Moving on to some next questions. I got about 20 more minutes that I would like to be on live. Thank you for everybody that's been on. I really appreciate the support that y'all have been giving. And if you're new in the stream, this is your first stream and you're here from Allen Bradley, we do talk about other things other than Siemens. We talk about different applications. This is really a motion, a motions platform, drives-based kind of channel. And so if you want to increase your kind of motion and drives kind of knowledge, then absolutely you can definitely get something out of this channel. You just might have to have. I try not to talk about Allen Bradley, but yeah, I do. I'm sorry ahead of time. So we have a couple other questions. It says, what is exactly a firmware version? It's SINAMICS in different lower versions and higher versions. Yeah, so we've got a question about the different versions in SINAMICS. And so you have some major version changes. For example, there is the SINAMICS 4.x to 5.x platform and change. Those firmware additions, a lot of times it's just small changes, but there are subtly some major features that get added into the firmware. I don't know where the firmware or what firmware change it was, but in the S120, somewhere along, I think it was 4.7 or 4.6, 4.7, somewhere around there, there was a feature called the inertia estimator that was added into the firmware. And that, we talk about inertia compensation and a lot of that, and like how to kind of like closed loop calculate your inertia. Well, there's actually a function built into some of the later firmware editions of the SINAMICS S120 that includes the inertia estimator. And so every time you start and stop, it's actually calculating the inertia of the load. And so you can use that value for feed forward pre-control. A lot of times it's bug fixes to where it's like, oh, hey, you have like these crossover point like manipulation. You have some weird fault condition that comes up that when if you have some feature, but there are, on the Siemens support website, there is what's called the for each edition, you can go to it and see the changes from previous editions. So you can go through and say, all right, what functions were added? What features were added? One of the major firmware additions, like I was talking about before, was the 4X to 5X editions. And from my understanding, the major difference between a 4X and a 5X is 5X is compatible with the 64-bit versions of starter. And so if you are working with a 32-bit version, then you aren't able to kind of go back and use you're not able to use the 5X versions. And while the 64-bit versions of starter are backwards compatible, you have to upgrade, you have to kind of update the starter version. And so the 5X versions were kind of the 64-bit kind of version changeover. One of the, so Claude, I'm going through your questions now. With the one also really cool thing that that is available on, what was it? Oh gosh, which was it? The built-in Profinet port. This is it. Okay. So I believe it was version 5X, or sorry, 5.1 or 5.2. I think it's 5.1. The built-in Profinet port on a CU320-2 has Ethernet IP available on that built-in port by default. So like, not by default, it's Profinet, but you don't have to add in a CBE20 module to get Ethernet IP if your version of firmware is 5.1 or above. So that's a major addition change. So the version to update or downgrade these versions, firmware versions, on a it has to do with either on a G120 it's going to be an SD card, on an S120 or with the CU320-2 it's a compact flash card. You go to the Siemens support website and download you download the firmware files from Siemens, and you can just take those with a regular Windows compatible card reader, compact flash card reader, or SD card reader, and you take the firmware file that you download from the support website and put it into the that card. And what will happen on a G120 will, if your firmware on the card and you put it into the card while it is powered on, nothing will happen. If you power cycle, you put it into it and you turn the control unit on, and the firmware on the control unit is different than the firmware that is on the SD card, it will perform a firmware update. Whether that is up or down, whatever firmware is on that SD card will get put onto the device, the control unit. Now, I will say some of these firmware updates will take a really long time. And I've noticed on the CU250S, I believe it's the DP, the Profi Bus version, it doesn't actually flash the correct way at the end of the firmware update. And so you just have to let it sit there for like 10 or 15 minutes before, and you're like, okay, I assume it's done. And then you can power cycle it. And when you power cycle it, it will see firmware on the CU is the same as the firmware on the SD card. No update. I go and boot up. So G120, it does that. The S120 is different because the S120 control unit itself doesn't actually hold any firmware, and it doesn't actually hold any software. So like that CF, the compact flash card on an S120, the CU320-2, it holds everything. So when you copy that file from, so if you copy that file from the, from all of the file structure and file folders from that you get the firmware onto the compact flash card, when it comes up, it will come up with a factory default setting CU320 of whatever firmware you put on that card. And then you'll just have to go through and take your program from starter and download the program anew. So the question is, you mean remove the CU flash card that has the program and insert the other flash card that has only the firmware file? You could do that. So Clyde, if you have an SD card that is in your CU320, or not CU320, CU240 or CU250, if you have one that's always in there, that you keep in there as like a backup, then you want to take that card and take the user, actually, you want to take the program from in starter and update that program and somehow get it. Because the problem with updating firmware on a CU3 or a CU240 is that No, if the program is forward compatible, if you're going up, then you will be okay. So if you're going from like a 4.10 to a 4, so if you're going from like a 4.8.10 to a 4.8.13, you won't have any issue. You can just take a firmware card or a card that has the 4.10.13 or 4.8.13 firmware on it. You can put it in, it will update the firmware and do that, like you said in your first one. So you pull out your program card that doesn't have firmware on it, and then you put your firmware card in, let it do the firmware update, and then put your program card back in and go. The only problem, what might happen if you do the other way, so you're doing a downgrade, if you have a program on that control unit, then that program might not be compatible with the new firmware. So you might get an error after you put your program card back in. And so that's kind of the issue with this. So you're kind of talking about the SMC20 and got a fault 30 that says the updated firmware in SINAMICS. So probably what happened is you may be on like a 4.7 dot whatever version of firmware that in your CU320-2. Since you are doing since you're on the S120, your firmware is the same as the program card, and so you're going to take the firmware out or take the card out, power down first, take the card out, and you will need to find the correct firmware that you need to go up to. And there are differences like in features and functionality. And as you found out, older versions of firmware aren't compatible with newer versions of like drive click hardware. And so what it sounds like happened to you is you swapped out an SMC20 to the newest version, and its firmware on that SMC20 is higher than the level of firmware that's on your CU320-2. And so what you'll need to do is update the firmware. How I get which firmware? So the fault itself, I mean, for SMC20, that is probably, I don't know which version it would be. I would have to know what version of firmware your SMC20 had, because there should be a compatibility chart for each version of firmware on the support website. So with the compact flash card in the S120, it's a bit different. Let me find this real quick on the website, the support website. And that will just help. We'll do this. See if we can go through it and find it live. Let me go to here, and I want this. Okay, so so here's 5.2 Service Pack 3 Hotfix 19. Let's see if there is a compatibility. Oh, that's a PDF. So these are the restrictions for this. Monitoring error, this is redundancy, blah, blah, blah. Nope. Control, web server, nope. Okay. So none of that is restricted on that. I'll have to find this other offline, and we could put it up in either Discord or send it to you as a message. But there's instructions for updating these, and I'm trying to find. I thought it was on here. Here you go. Oh, they put it. It used to have like this thing here, but it's instructions on how to update the firmware. But apparently, it's now in the function manual, so it's a little bit more difficult. But the corrected functional restrictions or the hotfix. So unfortunately, I'll have to go through and find a compatibility chart for your SMC20. But probably what you need to do is, if there's no hardware restrictions, if you're using the CU320-2, then you probably want to go all the way up to the newest, which is this version of that we just had pulled up there. And so, yeah, firmware version 5.2 Service Pack 3. I'd probably just go up to that, and you might have to download. Yeah, that is the issue. So, depending on what controller you have, you'll have to have a GSD for that issue. So I see there is a bit of a catch-22 there, isn't there? You need to verify that you can get a GSD file for that firmware edition. If you are using like a 300 processor or a 400 processor. Yeah, so what it sounds like is your it sounds like your starter version might be not the most up-to-date version, and so whatever the most recent version is, you might be using an older version of starter that doesn't have the firmware the correct firmware in it, and so yeah, the firmware update on an S120 is done by taking the compact flash card, using a card reader, and taking the file from Siemens. Here, let me link the support website. So, so you take and the you take this firmware and you put it onto the card, and the instructions are there on that website, and you probably would be able to translate it into, they probably have different language translations as well that might be helpful out as well. But so I think you had one other question. I'm sorry, I'm going through and looking at the questions. We had 3. Let's see, in these first master drive, second one. Third, second. Okay, so kind of talking, so you have a question kind of about load sharing. So we've talked about load sharing, have multiple drives that are all kind of trying to share one load. We've done a pretty cool or a pretty extensive load sharing topic, a whole live stream about load sharing. And one of the things is that it is possible to set up whether or not you are like a master or a follower in these setups. And there's two ways that you can make it to where you change, you are changing your like master versus follower setup. And the biggest thing is, if you want to change between masters and followers, I would set up both the master and the follower exactly the same, no matter what. And then all you are doing is changing the torque limits and changing the speed set point. And so what I would do is, if you have on your PLC, have a block or have a function, have code that is basically says, am I a follower? If I'm a follower, take the master's torque value, or actual current, take the actual current and put it as my current limit or torque limit. So actual torque put as my torque limit. And then I do that. And then I'm going to add so much to my speed, so modify my speed like we talked about in that load sharing video. Then if I am the master, then all I do is I say, okay, I get to run at whatever speed. So what is the system speed set point? That is my speed set point. And then now I need to take and transfer my actual torque into a variable called master speed torque. And then all of the followers, they know they're followers. And then you just have to have a way to kind of change that out. And you don't have to do it in the drive. You don't have to do it at the BICO level, because if you were communicating that way, you don't have to do it at the BICO level. Now, it might be to where you need to do it in the drive and you need to do it at the BICO level. And so if you're going to do that, then you will need to take the and have either two command data sets or two drive data sets. You can mess with command data sets and drive data sets. There's that way. And all you do is just say, hey, I'm a master, I'm a follower. Where do I look with the command data set? Like, what am I looking at? And then with the drive data set, that actually would probably work. Like, you could have, hey, I'm a master, use command data set 0. If I'm a follower, use command data set 1. And drive data set 0, drive data set 1. That's a pretty easy way to do it, or I guess that's one way to do it. Another way would be to have a bit that you're looking at, like I'm a master, I'm a follower bit, and you can set that up in. If you're communicating though, you would want to do it on the PLC. Have like a master follower switch. And bring that switch in, and you would need to have some way of like which one speed in starter. Actually, I'm not able to find which drive is following which one speed in starter. Yeah, so the way that I would pass that information. So let's go over to Portal. I'll show you what I have in. There is a bit in your Telegram. And so what you can do is, if you have a user data type. So I have this user data type called here it's called DriveTel 352 out. So this is my Drive Telegram 352 out, and this is how I use this. If honestly, your drive, if you are communicating via this sort of scheme, it doesn't actually need to know whether or not it is a master or a follower. That's part of the thing. If you have a PLC that is making all of the decisions for the speed set point and the torque limit, then it doesn't matter. The drive is just going to do what it needs to do. It just needs to be tuned to be able to control the motor in a proper way. So you don't really actually need the drive doesn't need to know. In one of some of my previous live streams, I've talked about ways that you could do this without a PLC. Like you could load share without a PLC, or you could load share on a single S120, because you can absolutely pass actual values from one drive object, one motor module, into another motor module on that. So let's see. Let me pull up a starter. If we just offset in third drive, it will impact on fourth drive, so on and so on. So okay, yeah. So let me pull up starter here. So this is a little far outside of the CIP block for sure, but this is bonus content. Let me get let's see if I have a block here. I don't quite understand why. I will say so if you're using SCADA, if we just offset in third drive, it will impact on fourth drive, and so on and so on. So your offset, it sounds like your offsets in your program aren't necessarily. You should have a data block for every individual drive. So here, let me think, because on starter, your starter settings, your start drive settings, like on the actual drive itself, all the drives are going to be set up exactly the same. They're going to be set up with their torque limit set to their upper torque limit set to the communication telegram and whatever it is, and that's really it. And then they'll have a speed set point that's coming in. The PLC itself is the one that's creating the offsets and is creating the torque limits. So what it sounds like may be happening is you have a either you're pointing your SCADA software to the wrong place in your the wrong place in your drive, or not in your drive. Your SCADA software is pointed to the wrong place in your PLC. You need to have individual blocks. So if you have four axes, you need to have all the same blocks, but 4 different versions of it. And so in your code, you need to take drive 1. What is drive 1's speed set point? Well, if it's a follower, then you're going to take drive 1's speed offset and add it to the system speed set point. So you have a system speed set point and then individual things that are getting sent out to the drives. So you go through and say, okay, I'm going to take my system speed set point, add in drive 1's speed offset, and then that gets sent over as the speed set point into the drive. So drive 1, drive 2, drive 3, drive 4, they're all exactly the same. Then, since drive 1, it's a follower, you say, okay, what is the master up here in this upper block, the system, what is the master actual torque value? Okay, and because it's a follower, it gets shoved down into the torque limit on that axis, and so it just gets sent into this thing. Let me draw it out a little bit, because it might just be difficult for that. So let me do sketch. Let me do paint. Let's do this. And let me actually bring up paint. So let's do this. So we have a you have something like this. So you have your drive, motors, so forth and so on. So this is in your PLC. This is a data block that has this is a data block. Let me make sure that I don't miss any communication here. This is a data block that has things such as so like system speed set point, and this is a okay, so these are the two values that you will need to be generating. So somewhere in your code, you're going to have like a block that determines who is the master. Oh, I see. So I'll go through and I'll finish this thought, and then we'll go through with yours. I see the problem here. Okay, so and then you would down here you would want to have like a speed offset for each one of like this on and on, and then you would have a bit that's like is master, so forth. And then all you would do is, if this is the master, you would say, okay, put my system speed set point so take this and pass this straight on, and then have the maximum torque value, just set it to 100%, and then so you would send that down. And then here, this is not the master, so it would take this speed set point, and then it would do set point plus offset, and then it would get sent down, and then it would say, all right, take this master value and send it down as the torque limit, and these would be the same. But I see that your issue is not this. So your issue is that the actual you don't have access to the S1 or the controller. Okay, so this is much more tricky. So let's go through and let's see if I can. I think I have a load sharing project here. Let's see. Where am I? Where's my open recent? Where's my open recent? I guess I don't have an open recent because I haven't opened. I had to reinstall this. Trying to find where we have where our program for our Sorry. So let's just do this. Maybe there's one here. Yeah. So I'll show you how to do this in if you didn't have it. So if you're just getting one speed set point and you're saying, all right, one speed set point and you're trying to cascade these down. All right, let me just insert another drive. All right, let's see if I can get this up and going. Not portal. We want starter. Is it gonna show us? Yeah, there we go. 8. All right, so we've got starter here. I don't think you can see that screen though. Let me just blow through and set up a drive. Okay. Because I'm going to show you, because the question is, how would you do this? How would you do this if, some motor with drive click. If you didn't have the ability to change a PLC and you're needing to drag these, you're trying to get these values from just through BICO. So I've got these 2 drives now. I should have expert lists for both of them. So what I can do, because these are on one control unit, I can go through and say if I go into the set point channel of this, so my speed set point, what I would probably want to do, so you're always wanting to pass. So you've probably got this S or 1200 is set up to communicate to one drive, and you're trying to cascade it down. So your other drives are always going to be a follower. So what you can do here is, if your follower is always going to be something, you can go right here and you can select this, go to further interconnections, and you have to go and select from drive 1, and then you can go to drive 1 and you can take the speed set point right here. R62, I think that might be the one that you would want. Speed set point after filter. Yeah, so that's what you would want. You want to take that, and so now you're actually taking drive 1 speed set point after the filter. So your 1200 PLC is communicating to drive 1, okay? So your 1200 PLC is communicating to drive 1. It's doing its thing. It's always the master. It's getting a speed set point. It has 100% torque limit. Cool, right? Well, now I'm setting up drive 2, and you would set up drive 2 and 3 to be the exact same way if you were wanting them to be enabled. So, and the way you would do this is if you set these drives up on like an on and off, if you turn them on, it'll automatically load share. So if you have 3 drives on and it's only sending 1, the master drive is automatically going to see that load sharing when you set it up this way. So the speed set point is here. So here's how you get that offset. So here's how you get the shift up. You can either do an additional set point of some percentage, or you can scale that by a certain percentage. So I want to say that there is a 105% scaling factor. Fixed value. That's 150. That's too much. So yeah, so what you can do, I know, just cancel this. So you can set up a fixed, oh wait, hold on. I know for a fact that I'm gonna find this. Sorry for everybody that's like, oh, this guy doesn't know. If you know what parameter the adjustable set point is, there's one that you can adjust that, I think it's this, 2900. Yep, that's it. So you can go parameter 2900, put this in here, and then you can go to your expert list and go to, no, that's on drive 1. Chat, I almost messed up, chat. Drive 1, drive 2, go to the expert list on drive 2, go to 2900, and you can actually set this to like 102%. And then that value can be, and so what will happen now is when you go back to this speed set point, you'll have this value and it's coming in at 102%. So that's your percentage offset. Now remember, we talked about at the lower level, you kind of wanted a few RPM just for it to be able to lock into. So that's where you would add in an additional set point, and you would use that 29 open drive 2, open drive 2 set point. So this is it, and then okay, yeah. So here's drive 2 set point, and I would set this to another, so this 2901. And then I would go through and I would set, I'm gonna hop over to the expert list real quick again, and I'm gonna set this value and I'll be right back to it. So let's try this being, because we want like 10 RPM, and so that's gonna be like 1% or so, right? So let's do 100, yeah, so 1%, and then I'm gonna go right back to this drive 2 set points. So here's like a well, it's a 3000 RPM reference value right now. So here's how you could, you know how you want your, we've talked about this before, in a follower axis at the low speeds, just having a percentage offset is going to, it's not going to lock that catch up into the, like when you're speeding up. So at the low values, a low percentage is only going to be like a tenth of an RPM or something. And so it's not going to be enough to lock in and saturate and load share during acceleration. So you want to kind of pop that in and saturate at that low RPM, and that's what this would do. So this is how you would set up all of the following axes, and each one of the following axes would have this same setup: drive 1, R62, and then you would go through and use your parameter 2900 and your 2901 in order for those offsets to be put in. So if your RPM offset came in at, say, 300 RPM here, and that is from the S120 or the PLC is communicating into that through that telegram. It communicates into the S120, and it says, all right, here's your master axis, and that master's taking its speed set point, and after the set point filter, which you probably aren't even messing with, but it's taking its speed set point and sending it over here. All of the following axes are going to be set up the same way, and then you're giving it the high speed saturation, so that 2% by doing this, and then you're giving the low speed saturation by doing this. Now, I'm going to hop over to the torque limits now, and one issue though that we have here is on the torque limits. Is you want to make sure that this value can ever go negative. So the upper torque limit, if your master ever goes into braking, this value, if we were to just say tie in here, go to drive 1, absolute, so it's torque actual value here. Okay, so if we did that, you would think, okay, we're good, right? No, because you would end up having trouble if your master ever tried to like brake. Like when you slow down, things would get weird. So what you need to do for this is, instead of using this torque actual value, we're just gonna go do this right now. But what we need is an absolute value function on that right there. And the way that we can get that, I don't think that they are enabled by default. So we're gonna have to go right click, properties, function modules, and enable free function blocks. So show you, I know I went through that again. So I went to drive 2, right clicked on it, and my program's processing the fact that I enabled free function blocks. So it's doing quite a bit right now. Oh, is it gonna crash? Is it gonna crash? No, it didn't. So I right clicked, properties, function modules, and then checked these free function blocks. Okay. Now when I go over to functions, I think there's free function blocks in here. No, they haven't quite done them. But in our expert list, we can go all the way down to, I think it's AVA. Let's check and make sure that this is the correct one. AVA for it's a absolute value generator with sign evaluation. Yes. All right. So we are going to put AVA into a runtime group. Just put it into whatever, runtime group 0. We'll set that here in a second. And then we're going to take, now we are going to take AVA input here, and we're going to select drive 1. And this is actually very vital if you're doing this. And we're going to look at its torque actual value. We're going to smooth it. And then now, remember this value, 129. Now we're going to go to our torque limitation. We're going to go here. we're going to go down to 2129. And we're going to use this. That will protect you from possibly losing your job. Just put it that way. If this value gets inverted, which it very much could, then you're gonna have you could have a bad day, because it tries to speed up in order to slow down, basically, and yeah. So very much, before you attempt this, go back and watch what I just did. Last thing, I will go back through, because I need to make sure that group 0 is set, that runtime group 0 is set. So 20,000. Runtime group 0 is, we'll just do it as fast as possible. Okay, so 1 times our base sampling time. So that's kind of very important. So free function blocks, like you just got a thing about free function blocks. If you didn't know, there is some like simple blocks that are on the S120. You just right click on the object over here, and you have to enable them. Go to properties, function modules, free function blocks, and you'll get these 20,000 parameters. And go through and make sure to set a runtime group 0. I set it at maximum 1 times the base sampling time. Normally that base sampling time, I want to say is like, is it 4 milliseconds? I don't know, it's something, but your none of these blocks they have to be tied to a runtime group, but you absolutely, if you're doing this, make sure to put an absolute value function on that multiplier. And also, if you notice, I did the multiplier and not the actual value. Check to make sure before you actually enable all this stuff that those values make sense. And so torque limitation, go back in here. This is going to come out as some sort of percent, and this is going to be the actual value. And so this is this torque limit upper. and so yeah, check the main set point. It is R22400. Interesting. So 22400. So that's coming from some sort of so if you're watching this on demand, communicating with one of the chats here, someone in chat talking about their S120 application, it's not able to identify which drive. So the 2200s are, I want to say that's the base for the DCCs. So, stream output. I mean, that's the main set point is the connector. So that's one thing. That's one thing about using the that different value that I used here. So in the main set point, so obviously I would make a backup of your program before you do much more on this, but every drive has main set point stream. Okay, so it looks like you have some sort of block. So R22400, like that is going to be coming from the extended parameter set, and I want to say 2200 is the base for DCCs. So So something is coming in, and it's being brought into a DCC chart somewhere, and it's getting processed out. What I would do is, because if your main set point, okay, if your main set point right here is coming in as like an R22, like you said, R22400, that's coming from a DCC chart. Well, here is what, whoops, you can take this value here, this R 1114 speed set point after direction limiting, and then you have there should be right here is speed set point. So you don't have to use you don't have to use the main set point. Yeah, so say for example, like if kind of all of this, if you have your main set point coming in at like R22400 right here, you can go over here and look R1114, and if I wanted to select R1114 from the drive 1, I should be able to do that. Yeah, so 1114. So you can kind of keep however the main drive is communicating. You can keep that communication the same. So if your master drive is connected to R22400, you can go through and change all of the other drives as, say for example, to this R1114, and that is this value right here. After it kind of brings in all of its set points, that is what the master drive is getting sent into all of its control parameters. So any conditioning and anything like that, then that would be that value. And then I would set your following drives up to be this way. And that is a way to work. Like, I mean, and then if you need to go back later, you can always go back and change these main set points back to that R22400, because R22400 is going to be on whatever drive your set point is, like the chart for your, like so for example here, this has a DCC chart called My Chart. And in this one, I can guarantee you that there are, because did we do this? Like what? No. Oh, so we loaded in, yeah, so 2200, it's right, is going to be a DCC chart. So I would almost guess to say that you have some chart here, and like when you go to like drive to set point, if it is on whatever, just pick something. So yeah, so if it doesn't say R, or it doesn't say drive 1 R22400, that means it is on that drive object, and 22400 is some sort of chart, and so it's an output of some DCC chart. If you're wanting to do this, then you can just bypass that DCC chart. I just don't know where anything else is going to be on it. So it's a little bit not quite as straightforward. This is a little bit more kind of like a bypassing bypassing a little bit of a little bit of the control from the PLC and putting it into the drive. And so you can always go to drive 1 and then select, like we said, that R1114. It's going to take whatever, and then you can do this right here. So take a look at this. Yeah, and we'll kind of go through, hit more up in the Discord or WhatsApp or whatever. We'll be able to kind of talk a little bit more about that. But this is how I probably would set this up. Just be sure when you do the torque limit to use that absolute value function. So right now, honestly, we've been going for a lot more than 2 hours. You got a lot of extra information towards the end of the stream there. Just kind of very specific about load sharing, kind of totally off topic from the CIP client block. But that's kind of what you get in some of these streams. I try to have a topic, and then we try to go on, and I try to help you guys out in whatever ways is necessary. And hopefully, even in kind of like this extra content, you can go through. I'll add in some chapters just about kind of what we're talking about in it. But yeah, for today, this is it. I will try to, for the next couple of weeks, do a little bit of content for you. Maybe get some edited content out here. Have at least one live stream next week, maybe not 2, but yeah, I appreciate everyone's support, especially to the members and that are financially supporting it. Again, I'm going to get these blocks wrapped up into libraries and get all of that updated to you to get out to you. Yeah, and so be looking for that as members. If you've made it this far in the stream and you haven't liked the stream, I don't know why you haven't, but yeah, if you're watching on demand and you're not subscribed, maybe consider subscribing, because we do a lot of this content. But I appreciate everything, that all the support that you give. If you've got a question and you're watching on demand, feel free to just drop in a comment on in the actual comments, and I will absolutely try to answer them if I can, and if not, I'll kind of do some research on stuff. But finally, hit up the Discord. Links in the description of the channel and this video. But I hope you have a great rest of your Friday for those here in the Western Hemisphere. And if you are abroad outside of the U.S., you're probably already enjoying your Friday evening. I hope that you continue to enjoy it and into your Saturday and your weekend. I hope you have a wonderful time. And yeah, as always, keep learning, and yeah, just always keep pushing forward. And I appreciate you all. Y'all have a good one.